specific embedded system design. So in the last part of the last video, we have seen washing machine as one of the application specific embedded system. So in the today's class, we will go for next example and we'll take the domain of automotive, right? So in the last semester, we have most of you have taken automotive electronics as one of the open elective. There you have seen right from the mechanical parts and how the electronics has been introduced and what were the reasons. The two important reasons were with respect to increasing the fuel efficiency. The second important reason was to reduce the exhaust emissions, right? The government has come up with the new regulations to meet the regulations. It was not possible only with the mechanical parts. So the researchers were forced to use electronic components to make automobiles more efficient and exhaust emissions to reduce the exhaust emissions. Okay, so here in this particular part of the module, we are going to see how embedded systems are being used for automotive or automobile, right? Automotive embedded systems are the one where electronics takes control over the mechanical systems. The presence of automotive embedded systems in a vehicle varies from simple mirror and wiper controls to complex airbag control, anti lock braking systems, ABS. Automotive embedded systems are normally built around microcontrollers or digital signal processor, or sometimes hybrid of the two, are generally known as electronic control units. The embedded systems which is part of any automobile, they call it as a particular name. The name is electronic control unit, or in short ECU, right? The number of embedded controllers in ordinary vehicles varies from 20 to 40, whereas a luxury vehicles like Mercedes S or BMW 7, it may contain around 75 to 100 numbers of embedded controllers. Okay, it is generally built around, as I told, digital signal processors, application specific instruction set processors like ATML, automotive AVR, and general purpose processors or controllers, systems on chips, programmable logic devices, application specific integrated and standard products, that is ASIC or ASSP, are also can be used, or a combination of all these. Okay, so then automotive embedded control units are generally known as ECU. This also I have explained. The presence of ECUs varies from simple mirror control units to complex ABS. The number of embedded controllers in an ordinary vehicles varies from 20 to 40, whereas for luxury vehicles, as I told, like Mercedes S or BMW 7, it may contain up to 100 ECUs. Government regulations on fuel economy and environmental factors and emission standards, right? And increasing customer demands on safety, comfort, infotainment forces the automotive manufacturers to opt for sophisticated embedded controller units within the vehicle, right? Now we have bar stage 6. Now that also forced many of the automotive industries to come up with the new electronic components so as to increase the fuel efficiency. The first embedded system used in automotive application was the microprocessor based fuel injection system introduced by Volkswagen 1600. That is the variant name in late 1968. The various types of electronic control units ECUs in automotive embedded industry can be broadly classified into two categories, that is high speed embedded control units, in short HECUs, low speed embedded control units, or LECUs. Now before going to this explanation of these categories, let me show you how much electronics has been involved in a today's vehicle or a car. Okay, here you can see, right? I have taken it from internet. Now this is a high-end car. You can see the amount of electronics within this, right from night vision, right, windshield wiper control, engine control, airbag deployment, adaptive front lighting, adaptive cruise control, automatic braking system, electronic power steering, electronic throttle control, electronic wall timing, idle stop start, right? Voice or data communication, DSRC, battery management. So latest car, a high-end car is full of electronics. More than around the money what you spend to buy a car, almost 60 to 70% of the amount we are paying for the electronics rather than the mechanical parts, right? You can search online also, you will get much more detail about all these electronic parts. Here just for your information I've shown few of them. Please try to explore some more. Okay, now let me go to the the two categories of ECUs, that is high speed electronic control unit HECUs and LECUs. In high speed, that is high speed electronic control units HECUs are deployed in critical control units requiring fast response. They include fuel injection system, anti-lock braking system, engine control, electronic throttle, steering controls, transmission control unit, and central control unit. Where we require high speed response from a electronic component, we go for HECUs. Now coming to low speed electronic control units like LECUs are deployed in applications where response time is not so critical, right? If you compare the previous ECU, their response was highly time critical. For example, ABS, obviously it has to stop the vehicle within the time, it has to respond. That ECU meant for ABS. Whereas here the application what we are going to see in LECUs, such as they are generally built around a low cost microprocessor or microcontrollers and digital signal processors. Examples are audio controllers, passenger and driver door locks, door glass control, that is power window, wiper control, mirror control, seat control system, headlamp and tail lamp controls, sunroof control units, etc. are examples of LECUs. Here, uh, the response time is not so critical, time critical. Even though if it misses the deadline, it's okay. It's not to result into some disasters. But whereas if you think about high speed electronic control units, the application where they are going to use this, they are highly time critical, like anti-lock braking systems, or we may be having the airbag systems also use high speed electronic control units. So in airbag, at least it has to respond in nanoseconds, not even microseconds, right? So let me close this video here only. In the next part of this module, we'll start with automotive communication buses. So there are three main buses are there. One is CAN, control area network, right? Then we have local interconnect network, LIN, and media oriented system transport, MOST. Those all things I will going to explain you in the next part of this module. Thank you.